Okay, so you know when you want to factorise a quadratic, you're trying to find the point where it crosses the x-axis. And we've got this one here, x squared minus 2x minus 7. I'm going to start with brackets. And I might try every single method I know. I might try finding the factors of 1 and 7, seeing if they'll add up to 2. I might try divorcing the middle set and say, well, that's 1 and 1. Does any of those two combinations make up 7? No. But I could spend quite a long time with that. I mean, I knew that wasn't going to factorise. So what could I do? And you might think to yourself, wouldn't it be nice if there was just a little machine that if I put in my formula here, it chundled about all over in here and came out with a, yep, yeah, it can be factorised, or, nah, don't even bother, I'm not possible. Well, funny enough, there is. Ta-da! It's the discriminant. So if we've got just a general formula, ax squared plus bx plus c, the discriminant is b squared minus 4ac. Great, you might say. But what does that actually tell us? Well, b squared minus 4ac, that's a number. We denote it the large delta, capital delta. But if it's just a number, how do we understand what that number's telling us? How do we decode that number? Well, if our delta, if our discriminant is greater than 0, so that number there is bigger than 0, then our quadratic has 2 real roots. Be warned, they might not be nice, but they're there. So our quadratic crosses the x-axis at 2 different points. If our discriminant is equal to 0, we've got one root repeated. So this is like y equals x squared or something like that, where the graph just touches the x-axis. And lastly, if our discriminant is less than 0, this is kind of the one we like, we've got no real roots. So we can't factorise it into 2 brackets. Our graph probably looks something like this. It's floating off the top. Doesn't touch the x-axis at any point. Okay, so let's try an example. Let's go back to our x squared minus 2x minus 7. So we're looking for the values for ax plus bx plus c. So we want b squared minus 4ac. That's our discriminant. So b in this case is minus 2, be careful. A is 1, there's no coefficient in front of the x squared, and c is minus 7. So b squared minus 4ac minus 2 squared minus 4 times 1 times minus 7, which is 4 plus 28. Which is 32. So actually, our discriminant, which is 32, is greater than 0. And this means that even though it looked like we just couldn't factorise our quadratic into brackets, we couldn't factorise it using just the standard methods. We might need to use completing the square or the quadratic formula to work this one out. But now we know. We know we can get 2 brackets. We can get 2 values for our quadratic. And that's what the discriminant does, and it's lovely.